What are you doing, Mr. G?
I'm looking for some logs.
But you gave them all to your students in their packets.
Oh, that's right. I forgot. Darn.
Hello there, this is Mr. Gonzalez. Hope you're doing well. My new philosophy is if I can teach from anywhere, you can learn from anywhere. So today's lesson is on logarithms. So what I have here for you is an example of logarithms. And this is called logarithmic and this is called exponential. Of course, you're very used to this because we just learned it in the previous chapter that this is a base and this is an exponent. This is our new topic. It's called logarithms, and LOG is the abbreviation of logarithm. So this is the way it's written and this is the way it is said. Log base b of y is equal to x. Now what you got to remember, most importantly, is that a log is always equal to an exponent. Can you repeat that for me 3 times? A log is always equal to an exponent. A log is always equal to an exponent. A log is always equal to an exponent. So here's your log equals to an exponent. This little guy here, it's always smaller in size, is called a base. This is what it equals to. Of course, it will be the exponent, as I just told you. And this here, y, is your answer. And the way to solve a log is for you to simply rotate. Now, yes, some of your other teachers are going to call it to swirl and to ballerina. But I'm going to say rotate. Why? Because I can roll my R's really cool. Anyway, the way to transform a logarithmic expression into an exponential expression is for you to simply rotate. You start with the little guy. As usual, we pick on the little guys. So we're going to start with the little guy and you're going to rotate. B to the power of x is equal to y. B to the power of x is equal to y. And that's as easy as you can transform a logarithmic expression into an exponential expression. So now let's give you some examples. Okay, take this one here for example. And of course, you see the words logs. Let's take care of the first one here. If I was to rotate, you would start with the little guy and you would transfer this into an exponential, which will give me 2 to the x is equal to 16. Well, previously we learned about one-to-one expressions, one-to-one equations. I can transform this into a one-to-one equation by saying 2 to the x is equal to 2 to the 4. And as we learned then, when the bases are equal, then the exponents are equal, so therefore x is equal to 4. Let's try the next one, see if we can get better at it. Once again, I see this one log, and one log you rotate, so I'm going to rotate here, and I'm going to go set that equal to 81. Again, 3 to the nth power is equal to 81. Now I can change this to a one-to-one expression by saying 3 to the n is equal to 3 to the 4th. And yet again, your bases are equal. Show me you cancel them. And n is equal to 4. Let's try it one more time. Again, one log, so you rotate. I'm going to rotate and show my arrows as I expect you to. And this is going to give me 9 to the y is equal to 3. Well, my goodness, how can I get this to work? Well, I need a common base, and again, we practiced this before. Transform 9 into 3 squared, 9, to the y is equal to 3. That will then give me 3 to the 2y is equal to 3 to the 1. Once again, the bases cancel, and all you got to do is solve that little equation there. 2y is equal to 1, so y must be 1/2. Pretty cool, huh? Now, let me show you a shortcut for those of you that like shortcuts. Let me erase all of this. Remember, my answers were 4, 4, and 1/2. Okay, so here is the shortcut. I'm going to use the same ones here. This only happens when these two have something that relates them. And you have both of these being numbers. Check this out. I'm going to leave the word log of 2, and I'm going to transform 16 to 2 to the 4. Well, one of the properties we've learned in logs is that when the base of the log is equal to the base of the exponent, they simply cancel. And whatever's left over is the answer, so x is equal to 4. Much shorter, huh? I like it too. Let's try this one here. I'm going to write the word log of 3, and I'm going to transform 81 to 3 to the 4. Yet again, the 3's cancel because when the base of the log is equal to the base of the exponential expression, they cancel, and so in this case you get n is equal to 4. Now this next one's a little bit interesting because it's not going to work just as easy. But I can still change this to log of 3 squared and then 3 to the 1. 3 squared being 9 and 3 to the 1 being 3, excuse me. So now you're going to notice that the base of the log is equal to the base of the exponent, and you end up with 2 numbers. Well, this is exactly 1/2, the 2 numbers, and so y is equal to 1/2. A little bit of trickery there, but still possible. But all of these examples here cover when x is on the right-hand side. What happens when it's not? So let me give you some other examples. Let me begin with this one here. Let's call this the log of 100. And so if you wanted to solve this, you're going to be saying, hey, mister, what happened? And I would say, there's something missing. Well, the base is what is missing, right? And so let me tell you now, whenever the common logarithm is missing a base, it's automatically base 10. So now we can go ahead and rotate. If I solve it for x, set it equal to x and solve it by rotation, which works 100% of the time. But I notice that there's a relationship here. So why not use a shortcut? Let me go ahead and do that. This is log base 10 of 10 squared. Cancel the bases, and the answer is 2. Right on. So what happens when the variable is not at the end of the equal sign? Well, let's take this one for example. Log base x of 2 is equal to 36. Okay? Well, I already told you if you rotate, because there's only one log, it'll always work. So let's try x squared is equal to 36. In case you're wondering where I got that from, I just rotated like that. So then, as you already know, to solve this equation, you take the square root of both sides and x is equal to 6. Now, some of you may be wondering, well, mister, wait a second, isn't that plus or minus 6? Well, it would be if this was a linear equation, but this is a log. And what you got to know is that anything that is related to the word log, whether it be the base or the answer here, cannot be negative. It cannot be 0. It must always be positive. So if I was to put plus or minus 6 and put negative 6 here, that log would be negative, and it's not possible. One more scenario, and that is what happens when the variable is elsewhere. We've done them all. So now let's put the log base 2 of x is equal to, I don't know, 3. Once again, one log, you rotate. Okay, so let me go ahead and rotate it. That's 2 cubed is equal to x. And as you already know, 2 cubed is what? Yep, you got it, 8. 8 is equal to x. And that is how you solve logs. Next, we're going to be doing some examples directly out of your assignment. So we'll see you soon. Remember what I said to begin with this lesson, and that is that if I can teach from anywhere, you can learn from anywhere. See ya. So today's lesson is going to be a review of the common logarithm. As you can see here, we have 2 different expressions. One of them is logarithmic, and the other one is exponential. And in this particular example, you're going to be seeing how we can transform a logarithmic expression, which is the one on the left, into an exponential expression, which is the one on the right. Now, you are already familiar with the one on the right here because it has an exponent and a base. It's called exponential form. But because this one here on the left contains the word log in it, a common log, it is called logarithmic form. In both cases, you're going to notice that they both have a base here and a base here. This is called the base of the log, and this is called the base of the exponential. And in both cases, they will both have an exponent. The exponent, obviously, on the right is up here. However, you're going to remember that a log always equals to an exponent. A log always equals to an exponent. A log always equals to an exponent. And so therefore, this log equals to an exponent. So in both cases here, x is the exponent. And a in both cases is the answer. You're going to notice that in the case of the log, the a is the answer here next to the word log. And the a is the answer next to the equal sign on the right here. Alrighty, so therefore, in this particular case, I was just showing you the difference between logarithmic and exponential form. You can also see it in this fashion here, where I put them again side to side, and you can see in both cases your basis, your base of your log, and your base of your exponential. You'll also see your exponent. The log always equals to an exponent. The log always equals to an exponent. The log always equals to an exponent. So x is your exponent. And of course here, x is your exponent. And A, your answer on the right-hand side. And of course, right next to the word log. You might also be able to see it based upon this little friend here. So this is my friend the snail. And it's going to remind you that whenever you have one log, you're going to rotate. This is said log base b of y is equal to x. So if you want to turn this into exponential, all you got to do is start with a base. As usual, we pick on the little guys, and so we're going to start with a little base, and we're going to rotate. Now, some of your teachers may call this to swirl. They might call it ballerina. I'm going to call it rotate, because you're going to rotate from your little b here, and you're going to spin around, and you're going to come all the way back to the y. In other words, you're going to start at the base, b to the x power is equal to y. And so you'll end up with b to the x power is equal to y. And that's our little friend, the snail. Okay, now let's try some examples. These examples are going to come directly out of the assignment that is called Logarithms Review Letter B. So you can follow along. I have selected mostly all of the odd questions so that we get to do the odd questions for you, and then you get to do the even ones and submit them later on. So here is example number 5. As you will see in example number 5, we have one log, and when you have one log, you rotate. So let us rotate. Of course, we're always going to pick from the little guy, and we're going to rotate from the base, which if I show my arrows, which I will be expecting you to do, it will look like this. When you turn this into exponential, this will be 3 to the n is equal to 81. Now we need to make this expression or this equation a 1-to-1. So I'm going to find a common base for both sides. This is 3 to the n is equal to 3 to the 4th power. Oh my goodness, it's now 1-to-1. So I can cancel my bases, and therefore my exponents are equal. So n is equal to 4. Interesting case when the log has a base of 3 and of 81 on the left-hand side, and these numbers have something in common. You may also be able to use a shortcut. What is this shortcut, you ask? Well, when this happens, you might be able to do this. So let me show you a shortcut. This is for those of you that like shortcuts. Log base 3, and you're going to transform 81 into 3 to the 4. Now, you're going to still set it equal to n, but you're only going to work on the left-hand side. What you're going to notice is that the base of the log and the base of the exponent, in other words, the base of this log and the base of this exponential expression, are both equal. They cancel each other out. Therefore, 4 is equal to n. Now, this doesn't always work because you don't have always variables that have something related to each other on the left-hand side. But if you notice that 3 and 81 do have something that relates them, then by all means try the shortcut. Okay, so now we have example number 7. In example number 7, once again, you're going to see only one log, so I'm going to rotate, and so I do so with my little arrows. Changing it to exponential will give me x to the negative 4 is equal to 81. But wait! My teacher told me that I should never have negative exponents, so let's make them happy. So I'm going to bring this to 1 over x to the 4th power. And that still equals to 81, and now all my powers or my exponents are all positive. So now I need to transform 81, and I will do so by leaving the left-hand side alone and changing this 3 to the 4th power. Now, you should notice there's a relationship between these, and that is that they are both sides are to the 4th power. So how do we get rid of a 4th power? Well, by its opposite operation, which is the 4th root. 4th root. And of course, the 4th root and the powers cancel. You end up with the 4th root of 1, which is 1. The 4th root of x to the 4th, which is x, is equal to 3. If I simply put a little 1 in here, so now we have a proportion, and all I have to do is cross multiply. Sauce. So you end up with 3x is equal to 1, and so x is equal to 1/3. Okay, let's try another one of those because negative exponent seems to always give difficulty to my students. So let me show you that it's not that difficult. Once again, we have one log. I'm going to rotate. And when I rotate, I will end up with x to the negative 2 is equal to 1/9. Once again, we do not like negative exponents, so I'm going to change this to 1 over x squared is equal to 1/9. Well, I recognize that they both are squares, so I could take the square root now, or I can change 9 into 3 squared, but I'm going to go ahead and do the opposite operation. And of course, the opposite operation of a square is square root. Or you can also sauce now if you wish. And that is that if you cross multiply, you get x squared is equal to 9. Oh, you should now recognize this. And of course, when you take the square root, which is the opposite operation, you will get x is equal to 3. Now, some of you may be thinking, wait a second, you said that every time we have an equation with a square root, that's supposed to be plus or minus. But I want to remind you that anything that is related to the log, meaning on the left-hand side, whether it's your base here or your answer, could never be 0, or it could never be a negative number. It must always be positive, and that is why this particular one is only positive 3. Okay, let's try another one. Number 11. Once again, I have only one log, so I'm going to rotate. And there goes my arrows. This is 2 to the 5th power is equal to y. So now all I have to do is solve this. Well, this one's an easy one because 2 to the 5th is 32. So 32 is equal to y. My goodness, they seem to be getting easier. Let's try number 13. Once again, I have one log, so I'm going to rotate. But you see what I did this time? I put equals to 0 on the left. So when you rotate, you're going to rotate to the left. Now, if you don't like it this way, you could always set it equal to 0 on the right-hand side and rotate to the right. But as usual, I'm going to pick on the little guy, and I'm going to rotate from the left, and this is what it would look like. Such that when I change this to exponential, this would be 5 to the 0 power is equal to 8 minus 3n. As you already know, anything to the 0 power is always equal to 1. So 1 is equal to 8 minus 3n. And all you have to do is solve this linear equation. I'm going to begin by subtracting 8 from both sides. So minus 8 and minus 8 is going to give me minus 7 is equal to minus 3n. And then when I divide by negative 3 on both sides, you're going to end up with 7 over 3. Can we get fractions? Of course we can. So long as they are positive, no problem. Okay, now your teachers may have also asked you to go back and double check to make sure that this is positive. And if you did, it's a very easy process. So let me bring it back because this is a log with an equation. So if I was to put 7 over 3 back here, which is my answer, the 3's would cancel. You would end up with 8 minus 7. 8 minus 7 is 1. So therefore, this whole log expression is positive. That's why this is a true answer and it is not extraneous. Moving right along to number 15 here. Again, only one log. By now, I'm an expert at this, so I'm going to rotate once again. And when you do so, I'm going to end up with 8 to the negative 1 is equal to 2x plus 1. But wait, I cannot have negative exponents, so let me change this to 1 over 8 is equal to 2x plus 1. And now all you have to do is solve for x. Now there are different ways of doing this. You can subtract 1 and then divide by 2, but you have to deal with fractions. But there might be a different way. If I multiply all of these by 8, which is your denominator here on both sides, then I might be able to get rid of all of my fractions and be able to solve a linear equation. In other words, on the left-hand side, you get 1 because the 8's cancel. And on the right-hand side, you get 16x plus 8 when you multiply everything by 8. As you can see, my fractions disappeared. Wow! And I can just solve this linear equation. By subtracting 8, that'll give me negative 7 is equal to 16x. And when you divide by 16, you get x is equal to negative 7/16. And I didn't have anything to do with common denominators. Yay! Let's try one more. And that is this particular log. And so you're going to see that I have only one log. So let me go ahead and rotate. But wait, I don't have anything to rotate from. Where will I start? Well, that's because you probably already know from the previous lesson that whenever you have a log, what is the common base? It is, yes, you're right, it's 10. My base is always 10. You don't have to write it, so when you see the word log by itself, it's a common log. It's always going to be base 10. Based upon that, then all I have to do now is rotate, which I will. This is 10 to the 0 is equal to 2 minus 3x. As you know, anything to the 0 power is always 1. So 2 minus 3x. When you subtract the 2 and take it over to the other side, you'll end up with negative 1 is equal to negative 3x. And when you divide by negative 3, x is equal to 1/3. It'll be positive because a negative divided by a negative is a positive. Now I will quickly check it to see if it is extraneous because the x is next to the log. If I put 1/3 back to the original one here, which I cannot see very well, but if I was to put 1/3 back in here, yet again the 3's cancel out and you end up with 2 minus 1. Which is a positive number. And so long as it's a positive number and not negative, it will always be a true log. Okay? Hope that helps. The next few questions will have to do with these properties of logs, which are, of course, in your notes. They're very easy to remember if you just rotate. You see, this first one here, if you were to rotate it, you would get a to the 0 is equal to what? Of course, 1. That means that the log of 1 will always equal to 0. The second one here is based on the shortcut that was previously taught to you, and that is when the base of the log and the base of the exponential are equal, they simply cancel out. And as you already know, there's an exponent of 1 there. Therefore, when these cancel out, you get 1. And that's why log of base a of a is equal to 1. The third and final one is yet again when you have common bases. Here, the base of the exponential, this is the exponential a to that power, and the base of the logarithmic are both equal. They're both a. Once again, when the base of the exponential and the base of the log are equal, they just simply cancel out and you get x. So we're going to be using these particular rules at this point to show you the last few examples from your assignment. Let's begin with number 17 here. Of course, I'm going to use the shortcut, the properties that I just taught you. But wait, this log doesn't have a base. Well, previously you just saw that whenever it's missing a base, it's automatically 10. And when you cancel the bases because they're both equal, the answer is 8. Is it really that simple? Well, of course it is. Let's keep trying a few more, okay? So this time I'm going to go ahead and do all of them on that particular part of the assignment because I want you to make sure that you understand it well. Okay, so here I have a base of 2 in my log. So I'm going to need to find the same base for my exponential. So I notice that 8 is 2 cubed. So I'm going to rewrite this as log base 2 and in parentheses 2 cubed to the 5th power. 2 cubed is 8. But I know my properties and my laws of exponents, and I know that whenever you have the power rule here, I'm going to multiply. So log base 2 of 2 to the 15th, because 3 times 5 gives you the 15th. Now I notice that the base of the log and the base of the exponential are equal, so I cancel them, and the answer is 15. Let's try it again. Number 19. I'm going to notice yet again that my base of my log is 6, and I can transform 36 into 6 squared. So I'm going to transfer this or change it into the log base 6 of 6 squared to the 10th power. Okay. Therefore, I am now going to use the power rule yet again, and I'm going to rewrite it as log base 6 of 6 to the 20. The power rule says that you shall multiply these here, which I just did. Now I notice that both of my bases are the same, so I can cancel the log base 6 with the exponential base 6, and my answer is 20. Getting the hang of it? Well, let's try a couple more, and then by then we shall call you experts. Here we go again, except this time I've given you a fraction. But I do notice that 7 and 7 are the same, and 49 is 7 squared. Interesting. Let me rewrite this as log base 7 of 7 to the 1 power over 7 to the 2nd power. And you're going to notice that this is going to be log base 7 of 1 over 7 because you subtract. Now, of course, you could have easily reduced this to 1/7 and would have given you that as well. However, I'm going to change this to an exponential by making it unhappy, which means a negative exponent. Log base 7 of 7 to the negative 1. Why did I do that when I've always told you to work with positive exponents? Because now my bases are the same and I can cancel them and you get negative 1. Let's try that one again. So now we're going to do number 21. It's my last example, and then this lesson will be finished and you'll be off on your way so you can try these on your own. Let's see, log base 3, I'm going to notice that 1/9 is 1 over 3 squared. Okay, but I still don't have common bases, but let me make sure that I do. I'm going to rewrite it as log base 3 of 3 to the negative 2. That means that when you bring it up, you make it unhappy with a negative exponent. That means that my bases are now equal, and so the answer is negative 2. I hope that helps with your homework. Remember, this is Mr. Gonzalez, and if I can teach from anywhere, you can learn from anywhere. Have a wonderful day. Bye.